delighted to be here at the last minute change, and hopefully you guys will want to know all about demand response. I always do this at the beginning. Does anyone know what demand response is? Fantastic. I prefer when people don't know, because then they're pleasantly surprised. So, the big picture demand response is a smart grid application. It's something which has been sort of innovative and now is mainstream in the States. It's something that's virtually unknown in the rest of the world, and we're commercializing it here in the UK and a couple of other countries. And people have really said demand response is the killer app of the smart grid, which is great and it's nice. But actually what it is, it's changing electricity consumption at peak times to avoid having to rely on peaking power stations. What does that mean? And we use this little graphic to show this is sort of the grid. So you have consumers on the right, and you have producers of electricity on the left, and 99% of the time, the grid is in balance. About 1%, or about 100 hours in any given year, we have a peak in demand, when it's a very cold day, when there's a sporting event on, when the Olympics are running, or whatever it is. To supply these additional requirements, National Grid calls on peaking power stations. These tend to be diesel or open cycle gas. They tend to be very polluting. They tend to be very, very expensive to run. Because of that, they run very infrequently. But if we didn't have them, we'd have a blackout whenever everyone switches on electricity at the same time. What we do, and what demand response does, is we install software and hardware at the grid. We install software and hardware at consuming sites. What we do is we turn down their consumption temporarily by a very small amount. By doing so across enough sites, we aggregate the portfolio. National Grid doesn't have to switch on a peaking power station. So if you think about it economically, rather than National Grid making a payment to these power stations, they're paying the consumers to be more green. That's the concept. So what we're really doing is we're turning this into this. We're turning very polluting, expensive power stations into smarter controls of our homes and our factories, and we're doing it really for three reasons. We're doing it because it's much greener. It's better to turn down some light or to turn down some air conditioning than to burn diesel. We're doing it because it's better for renewables. When we start integrating more and more renewables into a grid, the volatility of energy production goes up, because the wind doesn't always blow and the sun doesn't always shine. By managing the demand side, we can compensate for additional fluctuations of the supply side. And we do it because it's cheaper, because it's going to be cheaper to make a change in air temperature than it is to burn diesel. So I want to sort of show you a bit of a macro view about this. This is the low duration curve, and I'm sure it needs no explanation, but this is what National Grid put out. And this shows you how often we use what percentage of our generation fleet. And the important part over here is really the fact that that final 10%, so the final 10% of all the capacity in the country is used for less than 100 hours a year. So in the UK, that's about 5 gigawatts. 5 gigawatts of capacity used for just a few days. And when you sort of extrapolate this out and you look at the whole world, this is sort of energy consumption, production across the entire world. We've got about 5 terawatts today of electricity generation in total, which means around 500 gigawatts is peaking. 500 gigawatts used for just those few hours. And I don't think anyone has the capability of imagining what 500 gigawatts is, so I thought about it, and that's my animation over there. If you look at all these countries, all together, their entire consumption equals 500 gigawatts. So this is a list of countries that, if we could solve the problem of peaking power, that's the equivalent of having all of these countries be zero carbon. I think that's an interesting way of looking at it. That's today. And one more thing on the macro. In the future, this is sort of total energy versus total electricity, but this sort of principle applies. We're going to be moving from a world that uses 12 terawatts to a world that's using more like 30 terawatts in the next 20 years. So we're increasing our capacity. We're also increasing the slice that renewables plays, and this is conservative estimates. So both increasing consumption plus increasing renewables means the amount of reserves and the amount of peaking that we're going to have goes up and up and up. So that's the problem we're trying to solve. Last way of looking at it is in terms of price. This is sort of a chart that shows you the cost of production from different fuel sources. So cheapest, greenest is sort of hydro and nuclear, and then it gets more and more expensive and more polluting as you go up the stack. We're replacing the diesel. So that's great, and that's fantastic for the world. We work with companies in order to do this, and a company does this not because they want to save the world. They do it primarily because there's money in it. National Grid pays them to turn down their consumption temporarily, so it's good. They also do it because it's a green thing to do, and a lot of companies care about being green. They don't necessarily want to pay for it, so this is a nice way to be green without it costing anything. They help reduce CO2, and it doesn't cost them, and I'll sort of show you how. Quick slide on some of the people we work with. These are active life customers that are operational day to day. I'll walk you through a couple of case studies later. Going to spend a minute talking about how we do it. So we effectively split our process up into 4. Most of our time is spent on the first stage because this is relatively novel. Most people don't know about it. We go ahead and we educate customers that this is possible. We'll show them how to do it. We'll go ahead and do a site audit. So we will figure out for them what they can reduce and when. We'll install all the equipment. We have some proprietary hardware and software that actually does all the monitoring, does all the controls and the verification. We do the calibration, we operate the system, and then we bill. And when I say bill, actually we pay customers. So all of the stuff they get for free, we pay for all the upfront costs. They're not that expensive, and National Grid pays for it because it's cheaper than using a peaking power station. The kind of stuff we look at, I won't spend too much time on this, but if you want to see some case studies, come to our stand over here. Typically in a building, we look at anything that can be switched off temporarily or turned down without anyone feeling anything. So if you change the temperature in this room, for 10 minutes, no one's going to feel anything. It'll take longer than that to change, and that's the kind of philosophy. We also look at some generation. So if a building has a backup generator, that's a really good way, because if you switch on that generator, it's as if the site isn't consuming power from the grid. And we integrate with the management systems in the building to make it all automatic. Couple of screenshots, because as well as doing this and getting the money, we're installing some really high specification smart meters. It's power station grade metering, which is what National Grid needs. We've wrapped it up in some software we've developed in-house, and so our customers get an iPad preloaded with software that allows them to see a live energy dashboard, allows them to get some energy intelligence and smart metering, and then gives them actual reports. Our system is an end-to-end one, so when National Grid has a peak, they push a button, it initiates our portfolio to turn down. As soon as the event is over and the grid is back to normal, our clients get a report that says how they've done, how much energy they've saved, how much money they've made, and it's all automatic. Just a couple of customers that we work with. This is a picture of a potash mine in the north of England. We've been working with these guys for a couple of years now. It's a very dirty industry, and the capability of reducing carbon emissions for these guys was pretty limited. But by changing some of the set points and underground pumps, and by using some of their CHPs to do this, it's been a really, really good way for them to make money and to actually start sort of becoming more green. Very similarly, actually, we've had a contract with UK Coal for about a year and a half. We turned down their underground pumps at some disused mines that are used to keep the water level from flooding the mine. They have about a 2-day capacity before the mine floods, so if you switch them off for an hour, no harm done, and that works really well. We have a contract with Bournemouth Water. We've been doing for about a year. Again, it's some of the water filtration stuff, some of the water treatment stuff, and some of the generators that are used there. We have a contract with Sainsbury's. We run on about a third of their distribution centres now, and changing some of the process controls, changing some of the air temperature settings, and using their backup generators works really well. This is a hospital. We actually found that this is a really, really good thing for the public estate, and we have 3 hospitals running full-time now, with another more or less 8 or 9 we're implementing. This one is Lister Hospital. We use some of their systems, we use some of their generators. For them, it's really great because the hospital has backup generators that they use in case the grid fails. But testing your generator is an expensive process. If you don't test your generator, you don't know that it's going to work when it fails. By working with us, their generator gets a regular testing. It's got some extra maintenance on it to make sure that it runs. And they're generating hundreds of thousands of pounds a year of extra revenue that they can use to funnel into either other green projects or simply to beef up the resources the hospital has. That's it. That's all I wanted to say. So we're a startup. We're about 3 years old. We're operating primarily in the UK. We've got some pilots in other countries as well. We're about 25 people based here in London. Our real mission is to commercialize the demand response market in the UK and internationally, and get this to be a common feature of every grid. That's it.
Yeah, well, thank you very much.